We've learned a lot about taking equations and finding their derivative. We can even find the derivative at a single point by taking the derivative of the equation and then plugging in an x value. But sometimes we may want to be able to look at a graph and know something about our derivative. The key is to remember that the derivative finds slope. So the derivative and the slope are linked. So as we look at these points on this graph and try to determine if the derivative is positive, negative, 0, or does not exist, what we're really wanting to know is information about the slope. So as you look at point A, think about the slope at that point. Well, at A, we're on a decreasing part of the line, and if we're decreasing, then the slope has to be negative. So that means that the derivative at A would also be negative. So let's move on to B. We want to think about the slope at point B. The slope at point B is heading upward. It's increasing, so that means the slope is positive. Now C is at a funny point. C is at a corner. If you remember, a corner or a sharp turn is one of the three things that causes a derivative not to exist. So because of the corner, the derivative at C does not exist. Now D, to figure out the derivative, we have to think about slope. The slope at point D is increasing. The slope is heading upward. So our slope is positive, and that means our derivative is also positive. And finally, E is right on the top of a hill, so to speak. And that's not a corner, that's just a rounded normal part of the graph. So this actually will have a slope of 0. So that means the derivative is 0. If you think about the tangent line here, if we were to draw a tangent line, it would be horizontal. And horizontal lines have a slope of 0. So whenever you're at the peak or at the very bottom of a valley, for example, this would also, if I had that labeled as F, this would also have a slope of 0. Because it's not going up or down right at the peak. It just finished going up or down and is about to do the other, but it isn't actually doing either at that point. So when you're asked to find the derivative or describe the derivative at a point on a graph, the key is to think about slope.